Hello, I'm James Wahlberg, and in this video, I'll help you understand how to predict whether an electrode will gain mass, lose mass, or stay the same in a galvanic cell. Let's jump in. The first thing we'll have to decide is whether or not the electrode is inert or reactive. And what I mean by reactive is that it actually participates in being reduced or oxidized itself. An inert electrode does not itself become oxidized or reduced, but rather just passes electrons on to the species who are oxidized or reduced. So in the case of a reactive electrode, one that actually is directly involved in the half-cell reactions, we have to look and see which side, which half of the galvanic cell we're in. If we are in the cathode and we have metal ions in solution being reduced, those metal ions will stick to the electrode because the electrons are coming in at the electrode, and the ion in solution will pick up an electron, turn into the elemental form, and the electrode therefore will gain mass as metal ions come out of solution and form metal on the electrode itself. On the other half of a galvanic cell, in the anode side, when the electrode, again a reactive electrode, one that's actually being oxidized in this case, when the electrode is being oxidized and it loses metal ions, that means that the ions are leaving, going into solution, and therefore the electrode will lose mass. So for a reactive electrode, in summary then, at the cathode, the electrode gains mass. At the anode, the electrode loses mass. In the case of the inert electrode, where the material is not itself oxidized or reduced, nothing's going to happen unless there's a couple of specific events. So first of all, if we have only gases or ions, and if all of the species getting reduced or oxidized stay in these phases, either the aqueous phase or the gaseous phase, then the inert electrode will neither gain nor lose mass. It'll be unchanged. So that's the first thing. If you have an inert electrode and all the species are staying out of the solid phase, then the electrode's mass will not change. However, if the half cell contains ions that are reduced to a solid, and that's the key thing, whenever you are producing more solid in electrochemical galvanic reaction, that solid will be formed at the electrode, and therefore the electrode will gain mass. So that's what we have to look for. Are we actually producing a solid? And if so, even though we have an inert electrode, the electrode will gain mass as that solid is produced. Let's look at some particular examples. Here is an electrochemical reaction, and I see a salt bridge in this, so I'm suspecting it's galvanic. And we have, in fact, a meter, not a power supply. So yes, this is a galvanic cell, a galvanic system. So let's analyze the reaction. And I notice that we have iodide, I-, going to elemental iodine. So for the iodine to go from -1 up to 0, which would be the case for its oxidation number in the elemental form as solid iodine, then the iodide must be losing electrons, because minus and minus is a plus. So therefore our iodide, our I- is being oxidized, and that will be happening at the anode, of course. To track down the reduction reaction, this is a little more complicated, but let's zoom in on what's happening for our friend manganese here. I notice, first of all, that we end up with manganese as a 2+ cation. And manganese begins, it seems, as part of a polyatomic permanganate anion with a net negative charge of 1. Well, if you recall that oxygen typically has a -2 oxidation number for each atom, and there are 4 of them here, that means that the oxygen is contributing -8 to this permanganate ion, and therefore the manganese must be contributing a +7 because there is 1 negative left over. So that means that within this polyatomic anion, the permanganate, the manganese is in fact being reduced from +7 down to +2. So we found our reduction, and that will of course be happening at the cathode, where reduction always happens. So we've identified anode and cathode. And now let's see what we can make out about the electrodes. So we have here actually graphite or carbon electrodes here. I suppose they could be diamond. That's another form of solid carbon, or what is the other, Buckminster fullerene. But let's assume that we're doing this on the cheap, and this is graphite. So we have these inert electrodes in them. They're not participating in the redox reactions, but let's see if we suspect that there will be any change of mass. Well, first of all, if we look at the anode process, recall that iodide is being oxidized to iodine. And since that iodine is in fact a solid, we would expect that, yes, indeed, the electrode in the anode would be gaining mass as that solid is formed. However, in the cathode side, that graphite electrode is only going to be around aqueous species. We are not producing any solid species in the cathode reduction half reaction, so therefore there will be no change of mass for the other electrode. So here we have a system in which the reaction is written in standard electrochemical notation. Therefore, we have the anode on the left, and oxidation always happens on the anode. We have the cathode written on the right, and reduction always happens at the cathode. So we identified, therefore, the oxidation as copper is going from oxidation number 0 up to 2+, which means it's losing negative electrons. And iron is being reduced from 3+ down to 2+, so it is gaining those negative electrons. Therefore, yes, indeed, the copper reaction is happening at the anode, and the iron reaction is happening at the cathode. Well, since as the oxidation reaction happens at the anode, the copper is going from solid copper to copper 2+, copper cations, it will therefore be losing mass as that solid copper turns into copper aqueous 2+ ions. Those will be leaving the electrode, and the mass of that copper electrode will be leaving. So this is a reactive electrode, one that's actually participating in the redox process. On the other side, however, we have an inert platinum electrode, so solid platinum, but we have no species that are forming solids as they become reduced. Therefore, we predict that there will be no change to the mass of that inert platinum electrode because there is no solid formed in the cathodic half reaction. So those are the things to keep an eye out as you try to predict and understand what happens at electrodes. Just look for whether or not you have an inert or a reactive, and then see if you are forming any solid in the case of an inert electrode. That's it for now. Good luck with your studies of chemistry, and I'll see you in the next video.